Hello students, welcome again to Solochem Lab. Let us solve this problem on the board. It is a 2021 UTME problem. The problem goes this way. A reversible reaction is given. That is a reaction between iron and steam to give us Fe3O4 in solid form and hydrogen in gaseous form. And we are asked the equilibrium constant K of the reaction above is represented as some options are given and we are supposed to choose the correct option. Whenever you are given a reversible reaction like this on the board, which is expected to be at equilibrium, and you are asked to get the expression for the equilibrium constant, what are you going to consider? Consider species in gaseous form and make use of those species, only those species, in writing the expression of equilibrium constant of the reaction. That means, let's go and check. Iron is in solid form. We are not going to include it in writing the expression of the equilibrium constant of this reaction. Again, on the product side, we have Fe3O4 is also in solid form. Are we going to include it in writing the expression of the equilibrium constant of this reaction? No. We are going to consider only species in gaseous form. And let's check. On the reactant side, water is in gaseous form, H2O, that is steam. And then on the product side, we have hydrogen in gaseous form. Look at the solution given to us. Capital letter K, which is the equilibrium constant, is equal to the product, which is in gaseous form, hydrogen. We put it in square brackets. Do you know why we put it in square brackets? We're expressing the concentration of this species in gaseous form, the product. And then raised to power. Do you notice the coefficient that we have in the balanced chemical equation? The coefficient of hydrogen gas is 4. That coefficient becomes the power when we're expressing the equilibrium constant of this reaction. We take the product first, then we write divided by, go to the reactant. Do we have any reactant in gaseous form? Yes, that reactant is water, that is steam. We put it in square bracket because we're expressing its concentration. Raised to power, what's the coefficient here? 4. That coefficient becomes the power of this species in gaseous form on the reactant side. Do we have any other species on the product side which is in gaseous form? No. Therefore, this becomes the final answer. K equals H in square bracket raised to power 4 over H2O in square brackets raised to power 4. And that makes option C the correct option. Option C is the correct option. But you may ask, why do we not take into consideration other species in this chemical equation? Maybe the species in solid form or in liquid form. The reason is this: their concentration does not vary to a great extent. The concentration of those species does not vary to a noticeable extent. The variation in the concentration of those species is negligible. You can also say that those species are present in large excess, so their concentration does not change to a noticeable extent. That is why we do not consider them when we are writing the expression of the equilibrium constant of any chemical equation given to us. Is that clear? Do you understand? Do you still have any other question to ask about this topic? Do not fail to drop the question at the comment area of this video, and in our subsequent classes we'll look at that question. Thank you.